In question 3a, we need to define the amplitude of a wave. Well, this is the maximum displacement from the equilibrium position. In B part 1, other than electromagnetic radiation, we need to give an example of a wave that is transverse. Well, water waves are transverse. In part 2, we need to state one difference between transverse and longitudinal waves. Well, in transverse waves, the oscillations are perpendicular to the direction of energy transfer, whereas in longitudinal waves, the oscillations are parallel to the direction of energy transfer. In C, we have a diagram showing two identical polarizing filters, A and B, and an unpolarized light source. In part 1, if polarized light is reaching the observer, we need to draw the direction of the transmission axis on filter B. Well, for polarized light to get through the second filter, the transmission axis will have to be vertical, the same as that on filter A. In part 2, we have this chart, and we're told polarizing filter B is rotated clockwise through 360 degrees, about the line XY from the position shown in the diagram. We need to sketch how the light intensity reaching the observer will change as this is done. Well, at the moment, the light will be at a maximum. When the polarizing filters are perpendicular, the light intensity will be 0, reaching a maximum again at 180 degrees. Here they'll be perpendicular, so the intensity will be 0, and back where they started, it will be a maximum, giving a line something like this. In D, we need to give an application other than in education of a polarizing filter and a reason for its use. Well, polarizing filters are used in sunglasses to reduce the glare. They're particularly effective in stopping glare from light reflected off water, as this itself is polarized.